Hello, everyone. Good morning. I am Daniela Garcia, and welcome again to another edition of Encora Talks. Our topic for today is reactive programming and its applications. We have such a great speaker with us. His name is Sashir Estela. Sashir is a software development specialist with master's studies in software and systems, with more than 20 years of experience building software solutions for different industries. Sashir seeks to build software focusing on efficiency, quality, and agility, from architecture definition through technical design, development, testing, and deployment. Good morning, Sashir. Welcome to Encora Talks. We're very happy to have you here.
Good morning, Daniela, and thanks for your introduction. Okay, let's start. This is our agenda for our presentation. We were reviewing first the reactive systems. We are going to review some basic concepts about that. Next, we will review reactive programming topics, more technical topics, some concepts, some comparison with reactive systems. After that, we will review some prominent implementation for reactive programming. We are going to review the most notable tools and frameworks. After that, we will review a specific implementation called Project Reactor. We are going to review some specific topics about that. Next, we will make some evaluation. We are going to review benefits, caveats, when to use, when not to use reactive programming. Finally, we were answering some questions in the QA section. Okay, reactive systems. The first concept is reactive. What is reactive? Reactive is showing a response to a stimulus. As you can see in the image, we have a electrical reactive system where when you push a switch button, the light bulb is going to turn on the light. So in similar way, in our context, we have reactive systems that is showing a response to when data is changing, is reacting to that changing. Okay? Why we are talking about reactive systems? Well, in the past, about 2 decades ago, the context of the software and the systems were really complicated. What's changing? Because in that moment, people was starting using cloud computing in order to upload their system, to deploy their systems. Okay, the same way appear the multi-core processors. We have more capability to process the information. Millions of mobile devices were appearing. Every person could be handled more than one smartphone, for example. And the same thing is the Internet of Things. In Internet of Things, we have many devices communicating with each other. Okay, so a lot of information is passing through the internet. Another challenge is that people was expecting milliseconds in response times. Not just seconds, milliseconds. Okay. Finally, data is measured in petabytes. In the past, gigabytes was the unit measure, but now petabytes are even exabytes in those days. So you can see that was a really challenging context for developed system to develop software. So as a response to this challenging context, we have the reactive systems. What is reactive systems? Reactive systems is an architectural style that allow to multiple applications to communicate with each other, sending a message between them. Okay, in the graphics you can see many reactive applications working as a unit and reacting to external events, producing some information to external service. Okay, this is the big picture of the reactive systems. So in 2014, a group of software specialists, come together in order to identify what are the, the main attributes to define a reactive system. So they prepare a document called the Reactive Manifesto. In that document, they identify four main attributes for the reactive system. The cornerstone is the message-driven attribute. With the message-driven, the components can communicate via asynchronous messages. Okay, this is important because we could start working with different components in the coupled way. Okay, another important attribute is the elasticity. In that way, the applications can respond under varying workload. If the workload increases, the component can respond in good way, as well as the workload decreases. Resilient is the third attribute because we need to manage failures gracefully. We need to take in account the failures from the beginning of our designs. Okay. Finally, all of them points to the responsiveness in order that the systems could respond in a timely manner to the request. Okay, this is the core attributes for the systems, for the reactive systems defined in the Reactive Manifesto. Now let's talk about reactive programming. Okay, we were talking about reactive system previously. A reactive system, its code is a group of applications. But what about in the inside of the application? The application has its own challenges. So for that reason, reactive programming was born. So what are those challenges in the application? Well, we have the one thread per request. We can remember application servers like Tomcat, like JBoss, WebSphere application, etc. Those application servers was handling one thread per request. So we can have a pool of threads, but we cannot increase our attending the request because we have a limit. We have a physical limit in the operating system. Okay, so trade creation is a really expensive task because the context changing. Okay, we need to copy the content from one thread to another thread. So this is a really expensive task. This is another challenge for the application. When we need to communicate with external services like a database, file systems, we need to communicate with another, I don't know, system. So those communications occurs using the blocking I/O approach. This is the approach that components use in order to handle this kind of communication. So, but when you are blocking the I/O, our threads are blocked as well. So this is avoiding that we could increase the attention of the demanding request. Okay, but in order to handle this situation, we have some approaches in the different programming languages. We have callbacks, and we have future and promises in Java, but those approaches comes with some problems. We have for example, the callback hell anti-pattern. Callback hell is when you need to call a callback that needs to call another callback that needs to call another callback and so on. So this is a really complicated way to handle the logic in this context. Another challenge is handle the concurrency for the applications. We can handle, but it's not so easy to handle. We have different approaches. Okay, this is the context for an application. That was because we need a new approach that was called the reactive programming. Okay, in the past, in about the 2009, Node.js was created. Node.js was created with the goal to bring the JavaScript engine from the web, from the front end to the back end. Okay, JavaScript was an engine that was handling the requests using a single thread event loop approach. Okay, that approach was translated to the backend thanks to the Node.js. In that way, Node.js was able to handle tens of thousands requests, concurrent requests. Okay, so it was really impressive to have this approach in the backend side. Node.js was the first product handling that kind of amount of requests. Okay, it was supporting high concurrency. It was using the observer pattern. Okay, finally, when the request was completed in the worker threads, they could execute the callbacks in order to complete the functionality. Okay, it was Node.js was considered the first system handling reactive programming. Okay, so what is reactive programming? Reactive programming is a programming paradigm used to develop asynchronous and non-blocking applications. The main focus is handling data streams that we can observe in order to react to changes in that data stream. And also we have a mechanism called the back pressure. In the image, you can see the main components in the reactive programming. We have the publisher and the subscriber. Okay, the subscriber subscribes to the publisher in order to be notified when the publisher is generating events, is pushing events. Okay, and subscriber has a mechanism called the back pressure in order to communicate the publisher how many events the subscriber can handle in order don't overflow, don't miss data, because without back pressure, the subscriber can miss information. Okay, this is the definition of the reactive programming. Okay, let's make a comparison between reactive programming and reactive system. Some people used to confuse the terms, but it's important to separate them and identify correctly. For example, in the dimension of the nature, reactive system is a kind of architectural style. Instead, reactive programming is a programming paradigm. The scope of the reactive system is a group of applications. Reactive programming, his scope is inside the application. The communication in reactive system is message-driven, message-oriented. Message-driven means that the publisher knows or the emitter knows who is going to receive the message. Reactive programming handles the event-driven. Event-driven, the emitter doesn't know who is going to receive the message or the communication. The focus of the reactive system is distribute the load, and the reactive programming is handling the asynchrony. Okay, now let's review some important implementations in the reactive programming world. Okay, let's start with reactive string. Reactive string is a standard to handle reactive programming with back pressure even. It was created the first version was released in 2015. The last release in 2022. It was created, it was started worked by Netflix, Vital, and Lightbank, and other companies like Oracle, Red Hat, and Twitter. This standard proposed Java API interfaces. We have 4 interfaces: the publisher, subscriber, subscription, and processor. We're going to review more in the next slides. It is one of the most adopted standards. It's not the only one. We have another standard like Reactive X, but the most adopted in those days is Reactive Strings. Okay? Reactive Strings propose an API. In the left side, we have the four interfaces. We have the publisher, the subscriber, the subscription, and the processor. A publisher is the company who is going to, to publish or to emit the events, the changes in the data. Subscriber is going to be notified when the publisher publishes those events. Subscription represents the communication between a subscriber and a publisher. And processor is an interface that we can use when we want to handle an object that has a behavior like a subscriber and a publisher as well. Okay. In the right side, we have the typical communication sequence for reactive strings. We have an application creating a subscriber and a publisher. The application calls the subscribe method from the publisher, sending a subscriber. When this method is solved by the publisher, they create a new subscription that is sent back to the subscriber on the method, on calling the method onSubscribe from the subscriber, sending back the subscription object that was previously created. Okay, this is the beginning of the interaction. Well, publisher starts communicating the changes to the subscriber via the onNext method. Publisher calls the onNext method with each item in the data stream. Okay. If any error happens in the flow, publisher calls the onError method from the subscriber object. Okay. Also, we have subscriber can call the request method from the subscription, indicating a number. This is the back pressure mechanism. In this case, subscriber is communicating the subscription object that subscriber is going to receive only an n number of items from the publisher. Okay. In any moment, subscriber can cancel the communication via the cancel method from the subscription. And when the publisher completes the communication with subscriber, it calls the onComplete method. Okay, this is the typical communication sequence. Now let's review the most prominent implementation for the reactive strings standard. The first of them is RxJava. RxJava is a Java library created by Netflix. The first release is in 2013. In that moment, it was implementing another standard, the Reactive Apps standard. But those days, the last release in 2023, implements the reactive strings. Okay, RxJava supports Java 8 and plus or Android 21 and plus. RxJava is the main library used in the Android world for handling reactive programming. Okay, RxJava has many implementations for the publisher interface, but only one of them supports the back pressure. Is the flowable. The flowable class support the back pressure. We have another classes implementing publisher like observable, completable, single, and maybe, but they don't support back pressure. Another relevant library is Project Reactor. Project Reactor is a reacting library created by Pivotal, the company that creates a Spring framework. Okay, the first release was in 2014. It was implementing, as well as the as RxJava, Reactive Apps, another standard. The last release in this year implements Reactive String. It supports Java 8 and plus. Project Reactor has two classes implementing publisher. Mono, that we can use to handle 0 to 1 element, and Flux to handle 0 to many elements. Both of them support back pressure. Sorry. Project Reactor has a smooth integration with the Spring framework, with the Spring ecosystem, and also with the Spring Webflux. It's a product to handle reactivity for the web. Another relevant implementation is akka. Akka is a reactive framework from the company Livebend. The first release is in 2009, maybe it's the oldest implementation. It implements another model, the actor model, inspired by the Erlang language. The latest release was the last year, implements the reactive strings. It supports Scala and Java as languages, and the only class supporting or implementing the publisher interface is the source class. It supports back pressure, and it's a framework handling the message driven. We have another implementation. Vertex is our Java framework from Eclipse, the famous Eclipse company. The first release, 2013, using verticals, a kind of actor model. The last release in this year, implementing reactive strings. It supports Java, Groovy, and Kotlin languages, or JVM languages. The class implementing publisher is Reactive Bright String, supporting back pressure. Important feature is that Vertex interoperates with other reactive libraries and frameworks. It's important that. Okay. We were talking about some important or some relevant implementations from reactive programming, specifically for reactive strings standard. Now, we're going to make a quick review from one specific implementation, the project Reactor. Okay, this is the basic code of the interaction between a publisher and a subscriber. In the code, we have a static method, range, from the Flux class. In this example, we are emitting 5 items from 1 to 5. We are calling the subscribe method, sending back a new subscriber object that we are implementing at flight. Okay, in the subscriber, we have overriding. We are overriding the 4 methods, 4 typical methods for the subscriber: on subscribe, on next, on error, and on complete. We are just putting some messages in order to review how the communication happens. In the unsubscribe, we are just calling the request method from the subscription in order to tell the subscriber that the publisher, sorry, that the subscriber is going to receive just only 2 items. It's a kind of back pressure, just for demo. Okay, so every time that the publisher is detecting change in its data flow, in the data stream, their publisher is going to call the on next method. Okay, sending the item that he needs to communicate to the subscriber. Okay, so in the right side we can see how is the call stat, the sequence of calls. And at the beginning we have the on subscribe. After that we have the requesting to emission, the call to the back pressure, the on next for the one and for the first and the second items. After that, another call to the request, the third and the fourth on next calls, a third requesting call, finally the last on next call, and the on complete at the end of the flow. So this is the typical sequence of events when we are interacting between a publisher and a subscriber in the project Reactor framework. Okay, The implementations for reactive programming, in order to handle the data stream, they need operators. Operators are kind of functional uh, uh, functions, functions in the functional style in order to operate over the data stream, in order to create a new sequence, in order to transform, filter, to split, to group, etc. We have some examples. We have the range method in order to create a new data stream from n to m items. Okay, for transform a data stream, we have the mat operator. The mat operator, in this case, are applying a transformation to turn circles into squares, creating a second data streams. Okay, uh, for filtering, we have, for example, the filter operator. The filter operator applies and condition, evaluates the condition for every item in the data stream, and if the item accomplishes the condition, the item is sent to the second data stream. In this case, the condition is if the item is a circle. So both circles are created in the second data streams. Uh, Another example, the buffer operator. We have two arguments, max size 2 and skip 3. What does it mean? The buffer is grouping the items in the data stream from uh, two, two elements, max size 2. The third one is skipped and create a grouping other two elements. Okay, some examples of operators that we can use in order to handle it, the reactive programming. In fact, all the logic and reactive programming should be handled using operators. More features for the project Reactor. Well, all operator returns a flags mount, a publisher object, so they can be changed. Project Reactor has some modules in order to handle testing, supporting testing. Publisher are executed by default in the main thread, but we have scheduler objects in order to, to work in different threads. Okay, we have also, we can create cold and hot publishers. Project Reactor allow us to handle cold publishers. Cold publishers generate new data for each subscription, but hot publisher can start publishing data without any subscription. So when a subscriber subscribes to the publisher, to a hot publisher, the subscriber only can receive data from the moment that they was created. Okay. Project Reactor also has integration, small integration with Nedi, Kafka, or XJava. Nedi is an application system handling unblocking I/O operations in an asynchronous way. So it's the default application server for handling reactive programming, Nedi. Okay, Project Reactor also provides to us tools for handling the debugging and the monitoring, two operations that are really complicated. We are working with reactive programming. Okay, Project Reactor has a small integration with Spring Webflux. Spring Webflux is a component in the Spring ecosystem in order to handle the REST controller in a reactive style. Okay, this is very similar to the Spring MVC to handle the REST controllers, the typical REST controllers. The main difference is that instead of sending back an object or a collection of objects, when we are using Spring Webflux, we are sending back mono of objects or flags of objects, okay, in order to handle it the reactive programming style. And also we are using the reactive operators for data streams. Okay, as I mentioned before, maps, filters, groupings, etc. Spring Webhooks also provides a web client similar to REST client, but as uh, I was mentioned for the REST controller, we are sending back monos and flags objects. Spring Data R2DBC. What does R2DBC mean? R2DBC means uh, Reactive Relational Database Connectivity. Okay, this is a standard in the Java world in order to start using the reactive style in the database engines. Okay, typically the engines, the database engines to communicate with a Java program we're using is JDBC, Java Database Connectivity. But JDBC is using the blocking communication, blocking I/O communications. So in order to improve our enterprise application, it's necessary to include the reactive approach in the database components. Okay, it's similar to the JPA. We have we need to configure with a specific method with the connection factories. We need to create a connection object. We have also the reactive CRAB repository, similar to JPI repositories, in order to handle the CRUB method like find, save, delete, etc. Okay, and when we are using the R2DBC, also we are handling monos and flags for sending back the information. Okay, let's make an evaluation for the reactive programming. Okay, what are the benefits of using reactive programming? Well, when we start using reactive programming, we have scalability in order to handle a lot of requests and data streams. We we improve our performance. We have a better responsiveness. We have a better resource usage. We handle faults. We have fault tolerance. We have some simplified code just in the part of handling asynchronous events compared to multi-threading programming in the Java world, for example. Those are really good benefits when we are using reactive programming. But we need to review not just the benefits, we need to review the caveats, we need to review the drawbacks when we are using reactive programming. We need to take into account both sides of the equation. When you are using reactive programming, you have more complex, you make more complex your programs, your components, your systems. The programmers, the developers could have a steep learning curve to learn these new tools and patterns. The debugging and testing tasks could be really difficult when you are working with reactive programming. Even the latest version of the frameworks and tools are improving this part of the debugging and testing, but it's not so easy that when we working with the imperative style, when we working with the traditional approaches for handling, for creating systems. We could have some performance issues and compatibility issues because not all libraries are using the reactive programming. So you need to evaluate, you need to identify a balance between the benefits and the caveats for using reactive programming. Okay. What are the best use cases to use reactive programming? When to use reactive programming? Well, reactive programming is not a silver bullet for all the cases. We need to identify what is the correct situation. When you need to handle, for example, high performance systems, we are talking about, I don't know, banking, financial platforms, or real-time analytic systems. That is a good use case to use reactive programming, as well as streaming applications. I don't know, Netflix, YouTube, or handling sensor data in IoT platforms. Okay, we have a lot of information. So that is a really good case to use reactive programming too. When we are using distributed systems, so, using microservice architecture or cloud native technologies, asynchronous application is also a good use case. And finally, even driving systems such as chatbots or notification systems. All of them are good use cases to start using to apply reactive programming, to use reactive programming. But also we have the when not to use reactive programming. Well, if we have simple applications or application with low concurrency, we don't need to use reactive programming because we are going to introduce accidental complexity to your applications. So please don't use reactive programming in that situation. As well as when you are handling batch processing, or when your existing code base was created with another approach different to reactive programming, maybe not be worth the effort to refactor it to reactive components. Okay. I really like this diagram, this picture. It was created by Thomas Nurwitz. In this diagram, we have in the horizontal axis the project size, okay, from going from the small to large projects. In the vertical axis, we have the total cost of projects, okay, as a relative cost. Okay, in the orange line, we have the total cost for the traditional approach. And in the green line, we have the total cost for the reactive approach. So if you can see the diagram, we could realize that for small projects, it's more beneficial for us to use the traditional approach. Okay, traditional approach is better than using the reactive approach in small to medium projects. But we have some break-even point where the things changes, because now from that point it's more benefit to use the reactive approach. Okay, the author of this diagram called this break-even point the Netflix point. Why the Netflix point? Because he mentioned that if your project is similar to Netflix in the number of requests that you need to handle, yeah, that you can start using the reactive approach. Okay, so we need to make a conscious decision about when we are going to use the reactive programming. Okay, perfect. Now let's go to the QA section. Daniela, please. Let's wait for Daniela.
Hi, Sashir. Thank you so much for all this valuable information and knowledge you have shared with us. We are now ready to start with our Q&A section, as you just said. The first question I have for you is, you have shown us how to implement the reactive programming paradigm in GVM-based languages. Is there
Mhm.
a way to implement it for other languages like Golang, CSR, Python, etc.?
Oh, okay. Thanks for the question. Um, well, we were reviewing the an standard is reactive string standard. Uh, Reactive string, yes, is oriented to the JVM languages, Java, Scala, Kotlin, etc.
Mhm.
But there is another standard called Reactive Edge. Reactive Edge was created by Microsoft in 2011. Yeah, they create the first implementation was using uh, .NET languages, or C# language. So that standard, Reactive Edge, allows to create different libraries for different languages. So we can say that Reactive Edge is multi-language standard. And as far I know, there is some libraries for handle it. For example, for Golang, we have the RxGo. RxGo is a library that integrates in a smoothly way with Golang. Even you can continue using Go routines, and you can continue using channels. In the For Python, we have the RxPy. RxPy is another implementation, and well, for C Sharp, as I was mentioning before, it was created in 2011. So yeah, we can implement reactive programming in another languages different to Java or Java World.
Thank you, Zashir. The second question is, you mentioned that R2DBC is for reactive programming in the database side, but is it ready for production?
Oh, okay. Thanks for that question. Well, I understand that question because, well, R2DBC is a standard for handling the reactivity in the database side, but in the previous years they were working with the versions like 0.8, 0.9, but the last year R2DBC has delivered the version 1.0. So yes, now R2DBC is ready to be used in production. Um, Spring has some implementation, Spring Data R2DBC. In that implementation, you can use, we can handle transactions, we can handle batching. What we cannot handle yet is the ORM. ORM, we don't have ORM like we have in JPI. So if we need to handle, for example, I don't know, relationships like one-to-many, we need to make that part by hand. We need to create the queries by hand. But we have all the reactivity benefits when using R2DBC. Yeah, so I think that just in this moment, we are ready to use R2DBC to production. And I would like to add that this is in the relational world, but in the NoSQL world, we also have uh, uh, reactive implementations. In Mongo, for example, have reactive implementation in order to handle of this paradigm in the NoSQL side. Yeah.
Thank you, Zashir. The last question for you is, what do you think could be the future evolution of reactive programming?
Oh, what a great question. Thank you. Thank you for that. Well, I was reviewing the evolution of, for example, of Java. Java, as we know, is delivering a new version every 6 months those days. Uh, in the Java 19, Java was delivering a new feature called the virtual threads. Uh, called if I can remember, it was previously was called the Project Loom. Yeah. Uh, in with this feature, we can handle it virtual threads. So we could handle it uh, much more requests. So we can handle it blocking communications more easily, and easier in an easier way. So in the future, well, those days that standard virtual threads is not in the final version. They could change in the coming years. But I think that when they finally has a production version, I think that the providers could create some better implementations for the reactive programming using those virtual threads. Okay, so I think I see that it could be a great integration between reactive programming and virtual threads. So if we now with reactive programming we are handling tens or hundreds of thousands requests per second, with virtual threading, I think we could have, I don't know, thousands of thousands requests. So the future is really interesting for the reactive programming world.
Thank you, Sashir. Thank you again for answering all of these questions and for sharing your knowledge with us. And thank you, everyone, for joining us. Please keep an eye out for more webinars that we will be hosting soon. We also invite you to watch the recorded webinars we have posted on talks.incora.com. Thank you.
Thank you.